Mars is humanity's next great frontier, and we're exploring the best ways to get there. Elon Musk and SpaceX have outlined a 6-month journey using Starship, the fastest possible travel time with current technology, but even that still feels too long. Enter NASA, bringing forward a long-discussed but revolutionary solution, the nuclear rocket. This breakthrough technology promises to dramatically shorten the journey, offering speeds far beyond what Starship alone can achieve. However, it comes with risks and challenges that must be overcome. So, how is NASA developing this cutting-edge propulsion system, and what does it mean for Starship's role in the race to Mars? Let's dive into it on today's episode of Simplify Science. Nuclear power has long been regarded as a promising energy source due to its immense performance capabilities, particularly when compared to conventional energy sources. Currently, its primary practical application is electricity generation, but its potential extends far beyond that. NASA has long recognized the advantages of nuclear power for space travel. Decades ago, they explored this concept with the NERVA nuclear thermal engine project, but the program was ultimately cancelled due to safety concerns and shifting government policy. However, the idea is now making a strong comeback. Dale Thomas, a former associate director at NASA's Marshall Space Flight Center and now a professor at the University of Alabama in Huntsville, highlighted its significance, stating nuclear propulsion, either electric or thermal, could extract more energy from a given mass of fuel than is possible via combustion-based propulsion. A nuclear rocket engine operates on the principle of fission reactions. When a neutron collides with uranium, it causes the uranium atoms to split into smaller fragments, releasing an immense amount of energy in the process. This energy can then be harnessed to generate thrust. Compared to chemical propulsion, nuclear propulsion offers significantly higher efficiency and power. A nuclear-powered rocket can achieve much higher speeds due to its superior thrust capability, reducing travel time dramatically. Moreover, nuclear propulsion has a much higher specific impulse, meaning it can convert fuel into thrust more efficiently. This results in a propulsion system that is more than twice as powerful as traditional chemical rockets, potentially cutting travel time to Mars by half. Additionally, nuclear engines require far less fuel, making them more practical for deep space missions. Recognizing these benefits, NASA has already taken the first steps in developing nuclear-powered space flight. One of the most promising initiatives is the Demonstration Rocket for Agile CIS Lunar Operations, or DRACO, a collaborative project between NASA and DARPA. It uses high-assay low-enriched uranium, HALEU, a fuel source that is considered safer and more suitable for space applications than highly enriched uranium. The system operates by heating a propellant such as hydrogen or ammonia, both of which are readily available and efficient fuels. The heating process takes place within a nuclear fission reactor, reaching temperatures exceeding 5,000 degrees Fahrenheit 2,700 degrees Celsius. The heated gases then expand and create pressure, which is expelled through a nozzle to produce thrust. With this technology, NASA expects to reduce the travel time to Mars to just 45 days, an astonishing improvement over the current 6-month timeline proposed by SpaceX's Starship. This breakthrough has been met with enthusiasm from NASA officials. Former NASA Administrator Bill Nelson emphasized, with the help of this new technology, astronauts can journey to and from deep space faster than ever, a major capability to prepare for crewed missions to Mars. Similarly, former Deputy Administrator Pamela Melroy stated, DRACO will be a critical part of evaluating the technologies that will take us deeper into the solar system. NASA and DARPA have set a target to conduct the first test flight of the DRACO nuclear thermal engine in 2027, with ambitions to send a crewed mission to Mars in the early 2030s. Lockheed Martin has been selected as the contractor responsible for developing a demonstration version of the engine. Beyond DRACO, NASA is also working with General Atomics on another nuclear propulsion system. At the beginning of the month, NASA and General Atomics successfully completed the first test of a nuclear thermal propulsion system. The primary objective of this test was to evaluate how well the fuel could function under the harsh conditions of space. The test involved placing fuel samples inside a reactor and exposing them to extreme conditions. The reactor, which uses hydrogen, rapidly increased temperatures to over 4,200 degrees Fahrenheit 2,300 degrees Celsius. The fuel samples then underwent 6 thermal cycles, simulating the environmental stresses of space travel. Throughout the test, the fuel was also exposed to hot hydrogen, further assessing its durability. Additional experiments were conducted to evaluate various safety and protection features, yielding valuable data that will help NASA and General Atomics refine the materials used in the engine. The results were highly promising, demonstrating that the fuel remained stable even at temperatures exceeding 4,900 degrees Fahrenheit 2,700 degrees Celsius. This confirms that the NTP system is not only viable for space applications, but is also 2 to 3 times more efficient than current rocket engines. Following the test, Scott Forney, president of General Atomics, expressed his optimism, stating, "We're very encouraged by the positive test results proving the fuel can survive these operational conditions, moving us closer to realizing the potential of safe, reliable nuclear thermal propulsion for CIS lunar and deep space missions." Christina Beck, Vice President of General Atomics Nuclear Technologies and Materials, also highlighted the achievement. To the best of our knowledge, we are the first company to use the Compact Fuel Element Environmental Test, or CFET facility at NASA MSFC, to successfully test and demonstrate the survivability of fuel after thermal cycling and hydrogen at representative temperatures and ramp rates. Like Draco, the NTP system is on track for a demonstration mission in 2027. In addition to these two advancements, NASA is exploring yet another nuclear propulsion concept known as the Pulsed Plasma Rocket, PPR. This system is designed to leverage both nuclear and plasma explosions to generate thrust. Unlike NTP, which heats a reactor core, PPR directly heats uranium atoms, converting them into plasma. The system then employs coil gun thrusters and magnetic nozzles to accelerate and direct the plasma, providing highly efficient and precise thrust. Compared to other nuclear propulsion systems, PPR is expected to offer both high thrust and high specific impulse. Furthermore, its design is relatively simple, lightweight, and cost-effective. However, this technology is still in the early research phase and no specific development timeline has been set. Overall, nuclear propulsion represents a transformative step forward in making deep space travel more feasible and efficient. Shortening travel time to Mars and beyond would alleviate many of the challenges associated with long-duration missions, including the need for extensive life support systems, the physical and psychological toll on astronauts, and fuel and food supply constraints. However, nuclear-powered spaceflight is not without its challenges. Safety concerns regarding the production, handling, and operation of nuclear propulsion systems must be addressed. If something were to go wrong, the consequences could be severe. Stringent protocols and robust engineering solutions will be essential to ensuring the safety and reliability of these missions. As we stand on the brink of a new era in space exploration, the question remains, is nuclear propulsion the future of space travel? Share your thoughts in the comment section down below, and don't forget to like the video and subscribe to our channel to stay updated on SpaceX's journey to the stars. Now, could these potential advancements in nuclear propulsion affect SpaceX's Starship program? The answer is a resounding no. While nuclear-powered rockets could shorten the journey, Starship possesses numerous strengths that make it the more practical and immediate solution for Mars colonization. One of the most significant advantages of Starship is its schedule. While nuclear rocket technology remains in the research phase, unlikely to launch before 2027 and unlikely to carry humans to Mars before 2030, SpaceX is aggressively pushing forward. Musk has set an ambitious timeline, with the first uncrewed Starship mission to Mars planned within the next 2 years, around late 2026, and the first crewed mission within the next 4, around late 2028. If achieved, this would give SpaceX a significant lead, especially considering the growing competition from other nations, particularly China. Meanwhile, SpaceX continues to make substantial progress with Starship's orbital test flights, refining the vehicle with each iteration. Another key advantage is Starship's unparalleled launch rate. According to Elon Musk's projections, Starship will be capable of launching up to 10 times per day during each Mars transfer window, with a payload capacity exceeding 200 tons per launch. This means SpaceX could deliver over 1 million tons to low Earth orbit per transfer window, that's 250,000 tons of which could be sent to Mars. In practical terms, this means that within just 4 transfer windows, or roughly 8 to 10 years, Mars could receive the infrastructure and supplies necessary for a self-sustaining colony. Even if nuclear-powered rockets were faster, they would be unlikely to match this level of transport efficiency. Beyond propulsion, Starship's sheer size and payload capacity offer further advantages. Its ability to transport large amounts of cargo in a single trip will be crucial for returning Martian samples, transporting habitats, and delivering the machinery needed for long-term colonization. Additionally, Starship itself could serve as a temporary surface habitat, reducing initial construction requirements and saving both time and resources. NASA's nuclear rocket program certainly holds promise, but significant challenges remain. Historically, nuclear propulsion has faced difficulties related to cost, regulatory hurdles, and safety concerns, issues that continue to cast doubt on its near-term viability. A prime example is the Mars Sample Return program, which has struggled with delays and budget overruns. If nuclear propulsion follows a similar trajectory, it could take far longer to materialize than currently anticipated. What do you think? Are you excited about the future of interplanetary travel? Don't hesitate to let me know. This has been Kevin with Simplify Science. Don't forget to like the video and subscribe if you haven't already to stay up to date with yours truly and the latest details of SpaceX's progress. Thank you so much for tuning in, and remember, curiosity, imagination, and inspiration will always follow you as long as you keep looking up.